inequalities parts, systems of linear inequalities parts. This is off of the packet that reads systems of linear inequalities practice/review. So we'll just start with number one and we'll go right through the packet. What I'm going to try to show you guys again is just how you can look at some of these multiple choice questions and maybe decipher them without going through all the steps that you might normally have to with graphing inequalities. So number one gives you a graph, and then they're asking you which of these systems over here on the left, which of these things over here is this the graph for. Okay, so I look for certain things right away. So looking at the graph, immediately what I see are two solid lines graphed here. In other words, no dashed lines. So that means that the inequalities that I'm working with should all be, both of them should be inequalities that have an equals to sign underneath of them. Unfortunately, if you look at A, B, C, and D, all of them are all those kinds of inequalities. So we don't get the luxury of eliminating any of them right away, which kind of stinks, you know, but we'll keep going and see what else we can do. So I look at the graph and I see this top line right here. So I'm going to highlight this in purple. We'll see if you can see it. Hopefully that'll make it stand out a little bit more. But that line right there, I look at that and I see an intercept at +1, like this on the end, and it's a solid line and the shading is down, which says to me it should be less than or equal to. And then the other thing I would look at is what is the slope for that line. Well, I would want to find another point over here, how about right there, that's easy to count to. It's actually up 1 and right 3. Which means rise over run 1/3. So I need one of these things to say less than or equal to 1/3x plus 1. So it looks like A is okay. That's a good answer, maybe. B does not have that inequality in it, so that's no good. Neither does C, and actually neither does D. So having figured out just the first one, we've eliminated all the possible answers except for A. So again, like in this case, we didn't get to eliminate any of the most easy way, but we did get a good shot at eliminating them after writing just one inequality. So we didn't even really have to worry about the other line at all. Most of the time, this is what you can do with these problems. You can eliminate answers and not have to necessarily carry out the whole problem like you might have if you didn't have the multiple choice. All right, let's go to number two. It looks to me like it's kind of hard to see where the shading on this one is. Just to help you guys out a little bit, if you look really closely, some of these don't really come out very well, but this shading was supposed to be in this area right here. So if you couldn't see it on your paper, go ahead and color it in a little bit like that. So again, we have to find ones that match this graph. So the first thing I see is I see two inequality styles here, one that is dashed and one that is a solid line. So I'm going to highlight these two lines a little bit just to make them maybe a little easier to point out, so that when we focus on them, we'll be able to really focus in on the ones we want to look at. So we got that red one and we got the purple one. Okay, so when I see a regular inequality, meaning a dashed line, and then one that is an equal to inequality, meaning a solid line, that means that I need to have one of each. So if I go over here and look at these, okay, it looks like none of them have two irregular ones or two equal to ones. So again, unfortunately, I can't eliminate any answers from that. But a lot of times you can, so you might as well look for stuff like that, right, just in case. Okay, let's keep looking at some other stuff we can eliminate. What I see from the solid line inequality is that the shading from it is downward. Can you see how this gray shading is in the down part from the purple line? So that to me means that it's a less than or equal to. And the red line, its shading is also downward, but it is a dashed line, which means that it is a less than. So that means that when I look over here at these answers, I have to have problems, one of which has a less than symbol and one has a less than or equal to. So like for example, C can be eliminated because there are no greater thans in this problem. So C is no good. And the same thing goes for A because there are no greater than or equal to's in this one. So A is no good. So I'm down to B and D as potential answers. So let's see what I got. I look at the one that is supposed to be less than or equal to. It looks like it has a y-intercept at -1. So before I go any further than that, I go over here and I look and see y-intercept -1. Well, it's between B and D. D has y-intercepts at -3 for both of them. So it can't be D. So we can even stop right there and say that's enough to say that B is our answer. Because as soon as I recognize this line has a y-intercept at -1, the only one that even gives me that possibility is right here. So it's like, okay, I would stop there then, because I don't have to go any further. I've already had enough information to figure out the answer. But if you really needed to, you could always look at this and say, where's the next easy point on this line? I would say right here, which means that it's going to be a less than or equal to, but I'm going to have -1 on the end, and the slope would be down 3 and over 4, so -3 over 4. Right, so I could always say, well, which one has that inequality in it? And again, it would be B. But in this case, you didn't even have to go that far. Okay, so let's keep going, trying to figure out ways to eliminate answers, because I don't know if you heard me say it in your math class or not, but the real way to do math, there's two ways. There's calculating and there's understanding, and good math students know how to do both. So in this case, I think most of these problems are more about understanding than they are about anything else. In number 3, let's see if we can see what we got going on there. It's a little hard to see on the paper, but there is a dashed line right here going horizontally across the paper right there. And then we have the solid line, as you can see, up this way. So the first thing I look at is I look at that dashed line, and I know one thing is for sure: with a dashed line and a solid line, I should be able to eliminate any of them that don't have a regular inequality and one with an equal sign. So for example, A, see, they're both equal to inequalities. That's no good. One of them has to be a regular one. And it looks like the other ones I can't eliminate because of that, so we're stuck with these 3. But it's a little while ago, but these kind of lines, if you think about it, it's touching the y-axis and it's a horizontal line, so we don't have to write it like a y equals mx plus b kind of system. It's really just a basic equation, or in this case inequality. We're saying that this is a straight line drawn where it touches the y-axis at 4, and it's downward shading from it, which means less than, and since it's a dashed line, it's just a plain less than. So the inequality for that dashed line just says put a line where y is 4, make it a dashed line, and shade down from it. So we put a line where y is 4 and shade down. So right away I can eliminate this one because this says x, not y. And if you look at B and D, this one and this one are still possibilities. So the only question is, if you look at the rest of B and D's answer, B says less than or equal to 4x minus 4. D says greater than or equal to 4x minus 4. So they're exactly the same, except it's either less than or greater than. Well, if we look at the shading for our solid line there, that looks like up shading to me. So I would say it's greater than. So this one is no good. It must be this one. Okay, let's go back to one like number 4, where again we're asked to pick which of the graphs it is based on that system. Once again, the shading did not come out very well, so we'll go in and shade in the ones that are supposed to be the shaded areas. There we go. So I look at this, and again, the first thing I start with is looking at these inequalities. I see one that should be dashed and one that should be solid. So I can eliminate this one because there are two solid lines here. One of them has to be a dashed line, so we have to work with that. This one, at least so far, seems to be okay. So does this one, because there's a dash and a solid. But here again, in Z, they're both solid lines. One of them needs to be dashed, so I can take it out. Now I'll do something else very quickly too. I look at the solid line, and it's supposed to be a less than shading. So if I look at this one, here's the solid line, just to highlight it. Here's the solid line right here. And if I were to shade down on this graph, it would be in that shaded area, so that seems to be okay. If I look at Y, right, I'm doing this based off of this inequality, right? It's supposed to be a solid line, but it's supposed to have downward or less than shading. So this one is okay. So of the two that I have left, X is still good, possibly. So then I look at this one. Here's that solid line again. But look at its shading. That's up shading. That would mean greater than. So you can eliminate Y because it looks like it's supposed to be greater than shading for that. So we did that one wrong. So it is X because it's the only one that had one solid and one dashed, and the dashed line shading was down. So if you notice, we really had nothing to do with this inequality, and we were able to figure out the answer right away. So again, another one that is not going to make you go through all the steps to figure out the answer. Let's keep going. This one, it looks to me like while you have a word problem here, I don't really see any shading on the graph, and I can't really tell where the shading is. So on the surface I would say maybe we should skip this, but I don't think we need to, because we can actually write the inequality from the problem we have here. We can at least read them off what they're supposed to be. So let's look at the solid line and see if we can write its inequality there. So there's the solid line. Alright, we'll work on what the inequality is supposed to be. But we know it's a y equals mx plus b. Look at its y-intercept right there at -1. And it looks to me like there's a good point right there. So if we count up 1 and over 5, that would be 1/5 x minus 1. So our answer has to have something that is 1/5 x minus 1. So this one is no good. This one has a negative 1/5 x, but that's not what we want. We want positive 1/5 x. So we're down to one of these two. Let's see what the other equation is. It looks like I have an intercept at 0. So I would have like a +0 on the end. And then where is the next good point? It looks like it's way over here. So I would go down 1 and write 1, 2, 3, 4, 5, 6. -1 over 6. So of my two answers left, both the bottom ones were okay, but it looks like it's going to be this one, because this one says -6. Sorry, these are the two answers I have left. Let me repeat that for you. So from that graph I got a y-intercept of 0, and then the slope was down 1 and over 6. So even though I can't read the shading this time, I can at least write what the expressions would be. So down 1 over 6 is the slope. So of these two possible remaining answers, this one was okay and this one was okay. They're the same thing in both problems. So we were able to eliminate A and B because we knew they were wrong based off of this. But then we go to C or D, and I'm saying it has to be -1 over 6x, down 1, right 6. This one is fine, this one is no good. So the answer to this was C. So we didn't even really need the inequalities or the shading because it looks like it didn't print out very well anyway, or maybe they didn't even give it to us. But okay. Alright, let's go on to number 7, a much more common classic word problem for systems of inequalities. It says, Martha is planting a garden that will cover up to 400 square feet. I would underline that right there. Up to 400 square feet. So immediately when I see that, I think inequality. Up to means that it could be like a maximum of 400. So I can't go 500, right? I can go up to 400. That means 400 is okay, but anything less than that is okay also. So I'm saying less than or equal to 400 is what that phrase means. Okay, it says she wants to plant 2 types of flowers, daisies and roses. Each daisy covers 2 square feet and each rose covers 1.5 square feet. Okay, daisies cost $2 a piece and each rose $3 a piece. It says Martha doesn't want to spend over $500 on her garden. Okay, she doesn't want to go over 500. So to me, again, that means that we're talking less than or equal to 500. So our 2 inequalities will have those inequalities to start, and then we have to figure out how we put the x and y in. Okay, so maybe one of the tougher problems you'll have, these word problems, is they take a little bit of work before you can even bother to start working with the graph. So I'm going to slide over here for just a second so I have some space. And I know one of my inequalities that I'm going to write is less than or equal to 400, and the other one is less than or equal to 500. Okay, so the first one, the 400, dealt with the amount of square feet. Okay, so what do we know about square feet? Each daisy is 2 square feet, and each row is 1.5 square feet. Okay, so looking at the graphs, roses are on the x-axis, daisies are on the y-axis. So I'm saying x is number of roses, y is number of daisies. So for square feet, I know that the rows is 1.5 per row. So I'm going to write 1.5x, and I'm going to add that to the daisies, which are 2 square feet per daisy. You know what, I read that? Yeah, each daisy covers 2 square feet, so 2 square feet per daisy. So if roses are x, they're 1.5x, and daisies are 2y. That'll be our expression for that one. Let's do it for the money part of it. It says daisies are $2 each, roses are $3 each. So instead of 1.5x, now that I'm talking about money, the roses, each rose is 3x, and the daisies are 2y again. So those are the 2 inequalities that I'm trying to graph here then. So let's look at it this way. If I take the 1.5, let's focus on that first one. 1.5x plus 2y less than or equal to 400. And I'm going to make it so that I can graph it. I'm going to take the 1.5x away from both sides. That's 2y less than or equal to negative 1.5x plus 400. And then I'm going to divide it all by 2. Y is less than or equal to negative 1.5 over 2x plus 200. Now you might say, why did I leave this decimal in here? I'm doing that because my experience is going to tell me that I don't need to worry about the slope here. I need to worry about this part. This says that the line that starts at a y-intercept of 200 should have downward shading to it. And it should be a solid line, but all of our graphs have solid lines. So I'm just looking at these ones that start at 200. I'm going to highlight them for you here in purple. Okay? So on this graph, the y-intercept here is 200. So that line should have downward shading, and if you look at it, it does. So that one's okay. If I look at this one, here's the line that starts at y equals 200, and again it should have downward shading, and it does. Look at the line on this one. It starts at 200, See, if I shade down, none of that shaded area for the answer is part of where the downward shading would go. So we can eliminate this as a possible answer because the 200 line is shaded backwards. And so is this one. See, again, there's the 200 line. It's supposed to be downward shading. This is clearly up shading. So this one is no good either. So we've got to decide between W and X then. Well, we can use our other equation to do that. If we were to solve it all out, we would find out that it's going to be a y-intercept of 250, but honestly it doesn't matter. What matters is we recognize it has to have downward shading. So we're down to these two, so the other line has to have downward shading. Here's the other line right here. See, if you look at this other line then, that one is supposed to have downward shading also. For this graph it does. So W is still in play. If we look at this one, again, there's the line that we're focusing on. It's supposed to be downward shading. But if you look at it, none of our red shading is in this area. This is up shading for the red line. So we eliminate X because the other line is shaded inappropriately. So the answer to this is W. So I guess it would have been multiple choice answer A, W. Alright, if we look at number 8, here again, once again the shading's kind of hard to see, but it is up in this small little area right here. So I look at that graph and I say to myself, my graph better have two different kind of inequalities, one with a regular sign and one with an equal to sign. Because I see a dashed line and a solid line. So if I look down here, unfortunately I have that in each one, so we're not going to be able to get away with eliminating any from that. But let's look at that shading. Okay, from the solid line right here, you can see the shading is up. So that means it should be a greater than or equal to in here. So there is no, see this, less than or equal to, no good. Greater than or equal to, maybe. Greater than or equal to, maybe. Less than or equal to, no good. So how we eliminate 2? Alright, let's look at the dash line. Here's the dash line. Its shading is downward from it, so we should have a less than. So of our last two answers that are possible here, they have to have a less than, a plain less than. They both do. So again, we can't get away with eliminating all the answers here. But we're down to these two. So let's see if we can write an equation for, excuse me, an inequality for the solid line. Alright, what do I see? I see a y-intercept at positive 3. So I'm writing this. I know it's greater than or equal to, and it'll have a plus 3 on the end. So far, we still can't eliminate either one. This is a downhill slope. I look at the slopes and they're both negatives, so can't do anything with that. But let's see if we can actually calculate it then. The next good point is right there. So I would go down 1 and right 3. That's negative 1 over 3. So if I look at these two answers, there's that inequality right there. It has to be C, and that means B is no good. So we eliminated 2 of them, and then when we wrote the inequality for just one of the lines, we were able to figure out which of the remaining answers it was. Okay, we go to number 9. Maybe a little tougher. Maybe to start it out, we'll put slopes in here. Both of these are an understood 1 over 1. Unfortunately, we have plain inequalities, and all of these lines are all dashed lines, so we can't get away with that. One thing you can get away with, though, is if you notice, they're both positive slopes, so both of the lines in these pictures should be going uphill. Because they're positive slopes, you should see pictures of 2 uphill lines. See, uphill, uphill, uphill. Look at these are downhill lines. You can eliminate Z right away because they are downhill lines and these are both positive slopes. So between W, X, and Y, I see one that's supposed to be less than and one that is greater than. Okay, so let's focus on the top one. It has a positive 3 slope and the shading should be down from, or excuse me, a positive 3 y-intercept and the shading should be down. If I go here, here's the one with a positive 3 intercept. Its shading is down, so W is okay. If I go to this one, here's the positive 3 y-intercept. This shading is up. It's supposed to be down, so X is no good. And if we go to Y, okay, if I put a point here, its shading is supposed to be down. If I did that, you could see that this is still downward shading down here, so Y is maybe an answer. Let's look at the other one then. The other one says that the line with the y-intercept at -3 should be upward shading. Okay, here's the one with an intercept at -3. Shading is up, so W is still good. If we go to Y, here's the -3. We're saying the shading should go up. Well, if you look at that, this shading is below that line. So Y is no good because the -3 intercept line should have upward shading and it has downward shading. So we eliminate all the answers except for W. It looks like that would have been multiple choice answer B. Okay, I think we're on to one more. Hopefully you guys are getting the hang of these ideas of eliminating answers and such. Alright, so we've got these 4 graphs and it's supposed to be which one of these 4 graphs represents these 2 inequalities. Okay, right away I see 2 things. I see, first off, we should have one dashed line and one solid line. So I look through here. Look at W. Both of them are dashed. No good. Look at Y. Both of them are dashed. No good. X has a dash and a solid. That's okay. Z a dash and a solid. That's okay. So possibly X or Z. The other 2 have to go away right away. Okay, so what do I see here as far as the shading should be concerned? Well, both of them should be downward shading. So I need to look at the lines and say they are both downward shading. Okay, if I do the dashed line shading, it's down. Okay, and the solid line shading is down. So it seems like X should be a good answer. Let's check and see if Z also could be. Well, I see the solid line shading is down. Look at the dashed line shading. It's up. They're supposed to both be down because they're both less thans. So since this one has an up shading, Z is no good. It leaves us with just X as the potential answer. Okay, so we're going to leave this for you guys to look at. We're going to put about 6 or so inequality questions like this on the test. And then the rest of it will be very much the same test that you took here not too long ago, with the hope that you guys will look at some of the solution videos and maybe try to look over your old test to see what you need to look at again from the old material. But a good portion of your test, 6 or 7 questions out of the 40, will be from these systems of inequalities that we just did here recently.